Welcome to the next session of Strength of Materials. Today I am going to discuss about the objectives and outcomes of Strength of Material course. First, let me tell you that Strength of Material subject which I am talking about, the syllabus is common to both mechanical and automobile engineering branch. This is in semester 3 for both the branches. The course code of mechanical is MEC 302, and for automobile, if you have seen the previous video, I had mentioned there it is AEC 302. ME here stands for mechanical engineering and it is just replaced by automobile engineering as AE. The course credit for both is same, that is 3. So let's discuss about the course objectives, which you can see over here. The first course objective that is written here is to gain knowledge of different types of stresses, strains and deformation induced in the mechanical components due to the external load. There can be various types of loads like tensile, compressive, shear, bending, torsional. So because of these, there will be different type of stresses like tensile stress, compressive stress, bending stress, etc. And the same term will apply for strain as well. Deformation occurs in the body when there is some kind of supports and loading on the body. So these are the important things which you will be learning out of this entire course of Strength of Material. The second objective that is written is to study the distribution of various stresses in the mechanical elements such as beams, shafts, etc. So in this entire course, you will be studying about the stress variation on this element. You will be learning a module which is completely dedicated to stresses in beams, and another module wherein you study about shafts and the stresses which are acting on these elements. So this is another objective for teaching this course. If you look around, beams and shafts are very common elements, be it beams of your building or it could be any structure which looks like a beam in any mechanical element like the girders, or if you talk about shafts which you see very commonly in your fans or in any kind of motors, there is a shaft. So these are elements which are very commonly used everywhere. So it is very important to study the stresses which are acting on these mechanical elements and also likewise many other elements. So we will be studying all of these in Strength of Material course. And the third objective of learning this course is to study the effect of component dimensions and shape on stresses and deformations. Shape is very important factor based on which the stress and strain is going to vary on a particular body. Shape is one reason why Strength of Material has to be studied. If I give you a very simple example, you will see all around you the objects are never perfectly rectangle or perfectly squares. You will see that the edges are always given a small fillet. The reason is it gives a particular amount of safety to the person who is using it, because sharp corners are not something which is desired. And secondly, if you talk from material point of view, the stresses are always more in the notched edges. If you have something which is of a circular shape, you can actually reduce the amount of stress on the body by giving that shape. Having said that, also you can prevent failure of material at those points. So it is very important to study about the component dimensions, shapes. You are going to study about moment of inertia, a very important concept. More circle. You'll also study about columns. How do you design columns? How do you design shafts? So the shape is very important in every case. So these are the three objectives of studying the course Strength of Materials. Now let's go to the outcomes of this course, because this is the most important part. When you are studying something with some aim in mind, you need to get some outcomes, only then the study is going to be successful. So let's go for the first one. Demonstrate fundamental knowledge about various types of loading and stresses induced and draw the SFD and BMD for different types of loads and support conditions. In this entire course, you will learn about various types of loading which are there. For example, there is point load, there is uniformly distributed load, or there is uniformly varying load which act on the body. Also, there are other types of loads like a dead load. For example, a particular building will have some furnitures, or you can say a college, a lab wherein you're going to have your instruments. They're going to be bolted and they're going to be fixed over there. You're not going to shift it every day. So that is a kind of dead load. or you have a kind of fluctuating load. For example, students enter in the morning and they leave the college premises in the evening. So when they enter the building in the morning, the load of the building increases, and when they leave it in the evening, the load is going to reduce. These are just two types of loading which I am discussing. There are many more such types of loading. Also, because of these, there will be a stress induced and a stress reduced, say if the person is leaving. And we are supposed to draw the SFD and BMD of such kind of beams. Also, we are going to discuss about the support conditions. There are three types of support conditions which we mainly use. One is fixed, one is hinged, and one is roller. So these are the three support conditions which are there for a particular beam. So this is the first course outcome. You will understand all these things and you will be able to apply them and also solve the problems. The second one is analyze the stresses induced in basic mechanical components and estimate the torsion effect and strain energy in mechanical elements. Here I have just clubbed up 3-4 modules, and here you cannot see that module wise I have written a particular outcome. So you can see the analyze the stresses induced in basic mechanical components like your shafts and beams, and you're going to estimate the torsion effect on a particular shaft. And you can also calculate the strain energy in the mechanical element. Say if you are applying a load, the body is under the effect of stress. Stress will lead to some amount of strain, and when there is strain, the energy is stored in the body. So there is an increase or decrease in length. So the molecules go either apart or they come closer. So when there is a molecular activity, there is a change in energy. So this energy is nothing but strain energy which is stored in the mechanical elements. Let's read the third one. Analyze the deflection in beams. This is very, very important. We are going to deal with the deflection of beams. For example, in a building, you can see there are columns and there is a beam, any particular beam, and there are floors above in the building. So the above floor always applies load on the beam of the below floor. So when there is a load applied and when you have supports, obviously there will be some deflection in the concrete, but the concrete is nowadays reinforced with the steel bars so that the steel bar is able to handle more of the load. So you can see that over a period of time, if you just break the concrete a little bit and you can just peep into, you will see that the reinforced bars have got slightly bent. So that is nothing but the deflection in beams, and it is something which definitely happens over a period of time. And the fourth one is analyze the buckling and bending phenomena in column, struts and beams. This is absolutely important. You need to know the buckling and bending phenomena which occurs in the beams or your columns and struts. Struts basically means short column. We don't study mainly about struts because when you have a load applied on a strut, it just fails because of compressive load. But column basically means a long column. Long means when I can say that the length by another dimension, a lateral dimension ratio is greater than 12. We say it's a long column. And in such long columns which you see in your houses, what happens is when the load is applied, it's not only like breaking because of compressive stress, it will also undergo some amount of bending. So a vertical bend is nothing but buckling. So we are supposed to study about this, and we will be able to understand what are these phenomena and how they are applied everywhere. So these are the outcomes of strength of material subject. Now the most important part which I have added over here, I just wanted to add it somewhere, so I added in this lecture. That is, how is the question paper pattern of Mumbai University? You need to know that the question paper of Mumbai University is generally of 120 marks. There are 6 questions in all. You have to solve any 4 questions. If you see the previous lecture, you will know that the theory paper is of 80 marks. So if it is of 80 marks, you have to solve 4 questions. Each question is of 20 marks. So out of 6, you have to solve 4, in which question 1 is always compulsory, that cannot be avoided, and amongst the rest 5 questions, any 3 has to be solved. So from question 2 to 6, in between this, you have to solve any 3 questions. So this is the question paper pattern. Generally the first 2 semesters and third semester onwards, the paper pattern varies a bit, and also the marking scheme. So rather than being confused, you can just know this. So this is all about the course objectives, course outcomes, and the paper pattern. If you have any queries regarding this video, let me know in the comment section. Don't forget to like, share and subscribe to my channel. Hit the bell icon for latest updates of my videos. I'll see you in the next session of Strength of Materials. Thank you.